teachers and friends, my name is Ariqah Nabilah from class TL1. Today, I'll be presenting the experiment on diphenhydramine quantification in syrup. These are the things I am going to cover today. This is the overview of the experiment. The objective of the experiment is to extract diphenhydramine hydrochloride from two different brands of syrup using SPE, which is solid phase extraction method, for the analysis in high-performance liquid chromatography (HPLC). Background information on diphenhydramine is that it is an antihistamine drug that is used to treat allergic symptoms. Additionally, it is used to treat kinetosis and vertigo. It can also be used to treat insomnia. Before analyzing the sample in HPLC, it is important to do sample preparation steps. The purpose is to prepare samples for analysis. This helps to prevent contamination and improve accuracy. SPE is used as the chosen sample preparation for this experiment. This type of sample preparation is useful for concentrating different types of sample and for removing compounds that interferes with the analysis by HPLC. Syrup has a complex formulation and it contains many excipients as well as API. Diphenhydramine is different compared to other syrups as it cannot be detected using one-step syrup dilution. This is due to their molecular extinction coefficient of about 500 liter per mole cm at wavelength 260 nanometer. This means that in order for them to have a significant signal at that wavelength, relatively high concentration of active ingredient is required. Without sample preparation, there's a huge amount of excipient instead. SPE is preferred as a faster and easier method compared to LLE, which is liquid-liquid extraction, as it only takes 5 minutes. Now I'll be talking about the materials and reagent. The materials include vacuum pump, 12 pot Supelco SPE equipment, 5 ml flask, and chromobond cartilage. This cartilage is made up of polystyrene polydivined benzene. The extraction mechanism used is reverse phase and ionic exchange. The stationary phase is nonpolar and it is used to extract nonpolar basic drug. Reagent include lidocaine hydrochloride, distilled water, acetonitrile, and eluting reagent, 4 ml ammonium at 5% acetonitrile. The procedures are: first step is to dilute 3 ml of lidocaine hydrochloride aqueous solution with 7.5 mg of syrup solution. The lidocaine hydrochloride acts as an internal standard in the sample preparation. Step 2 is to condition the cartilage with 3 ml of acetonitrile, flush the column with 7 ml of distilled water to remove the acetonitrile, and make sure not to dry out the stationary phase during conditioning. Conditioning is necessary to produce an environment that is suitable for absorption of the analyte of interest. Step 3 is loading. Pour the sample mixed with internal standard solution, which is the diluted sample in step 1 into the column. The fourth step is to prepare a 50-50 solution. Add approximately 3.5 to 5 ml water and approximately 3.5 to 5 ml of acetonitrile. Step 5 is washing step. Firstly, wash with 5 ml distilled water. Rinse with 7 ml of solution prepared in step 4. Because the solution is polar, based on light dissolved light, polar substances or excipients will interact with the solution and get washed away by the washing solvent. Remember to dry the column completely before the next step. The last step is to add 4 ml ammonium at 5% in acetonitrile, which is a weakly alkali organic solvent, to elute analyte of interest in 5 ml flask. This is because diphenhydramine hydrochloride is nonpolar, so it will be retained in the stationary phase. To determine the quantity of diphenhydramine hydrochloride, the sample will be diluted with mobile phase and injected into the HPLC system. Thank you for your kind attention. These are the references.